Okay, so now let us quickly solve the last part of question number 2 of exercise 4.3, which says that find the roots of the quadratic equation given in question number 1 by applying the quadratic formula. Okay, so if you see the question number 1, the last part is given as 2x square plus x plus 4 is equal to 0. So this is the given equation. So we have to solve this equation by quadratic formula. Okay, so I'll again quickly write the quadratic formula. In a standard quadratic equation which is given as ax square plus bx plus c is equal to 0, where a is not equal to 0. Okay, this is a standard quadratic equation. Here if we use the quadratic formula, so quadratic formula say that the value of x is given by minus b plus minus square root of b square minus 4ac upon 2a. The expression which is under this square root is called determinant d. So if this value is less than 0, so in that case the roots of the quadratic equation does not exist, and if they are greater than or equal to 0, then the root of the quadratic equation exists. Okay, so now let us compare our given equation with the standard quadratic equation. So from here we can very easily find out the value of a, b and c. So if we compare, so we can very easily find out that the value of a is 2, because the coefficient of x square here is a and here is 2. So value of a is 2, the value of b is 1 and the value of c is 4. Okay, so now let us quickly put these values into the quadratic formula. So by quadratic formula, x is equal to minus b is minus 1 plus minus square root of b square, so b is 1 square minus 4 into the value of a is 2, the value of c is 4 divided by 2 into a, the value of a is 2, right? So if I'll solve it further, the value of x is minus 1 plus minus square root of 1 minus 4 into 2 is 8. See here, this 4 into 2 is 8 and 8 into 4 is 32, minus 32 upon 2 into 2 is 4. So x is equal to minus 1 plus minus square root of minus 31 upon 4. Now here, as you can see, that we cannot take the square root of a negative number, so the root of this equation cannot be found. Okay, so if you remember the question number 1 again, there also when we had checked for whether the root of the equation exists or no, the value of d was less than 0, so in that case also the root of this equation were non-existent. So we can write, because d, which is equal to b square this value of d, b square minus 4ac, it comes out to be minus 31, which is less than 0. Hence, therefore roots does not exist.